Alright, now this section, again, we have multiple logs on one side. Now when it comes to x squared, which you will see later on, that means that there's going to be two solutions, which is going to be extraneous solution. So for this section with extraneous solution, that means that you have to check for both solution if one works, if both works, or neither works. So that's what I mean by extraneous solution. When you have more than one, and you have to check if one works, or the other solution works, or two solution works, or none at all. So in this example, we have log base 2 of x plus log base 2 of x minus 3 equal log base 2 of 28. Now again, when we're solving a log equation, we always have to have one log or one natural log on the left side, one log or one natural log on the right side. Here, we have two logs with the same base on the left side. So if I were to combine as a single log of base 2, again, I would have to apply one of these three properties. So since, again, two logs with the same base, and it has a plus in between them, a plus between these two logs, that means I'm going to use the product property. So I'm going to multiply what is inside the parenthesis. So log base 2 of, and I'm going to use bracket so that you can easily see what's working, what's going on. So x from here, and then x minus 3. And then I'm going to close bracket. So again, I'm applying the product property, combining these two, or condensing these two as a single log base 2, and then multiplying what's inside the parenthesis. On my right side, we have one log, so that's okay. Alright, so again, on my left side, I have a single log base 2, but also inside is x times x minus 3. So let's write that out. So log base 2, so x times x is x squared, and then x times minus 3 is minus 3x, and then equal to log base 2 of 28. Alright. So we got one log on the right side and one log on the left side. And they both have the same base. So it follows the one-to-one property. That means we can set what's inside the parenthesis equal to each other. So it's going to be x squared minus 3x equal 28. Alright, so we have x squared minus 3x equals 28. So now we have two x's in this equation, but they're different. This is x squared and that's just x. So this is going to be a quadratic equation. So that means you're going to have to factor this. So in order to factor any equation, you got to make sure that everything are on one side. So if it's on the left side, make sure everything's on the left side. If there's parts on the right side, make sure everything is on the right side. So when we're trying to have everything on one side, we always look where the x squared is located. If the x squared is positive, it's going to stay on that side. In this example, it's on the left side, so I need everything on the left side. So here I have 28, it's on the right. If I want to get rid of 28 from the right side, I'm going to do the opposite of 28, which is negative 28, and I'm going to subtract on the left side. Whatever I do on the right side, I can do it on the left side. Alright, so x squared, nothing I can combine with, No, 3x minus 3x, there's nothing else I can combine. And then minus 28 is just a number, so minus 28 equal 28 minus 28 is 0, so on the right side is 0. Now again, I'm not combining negative 3x and negative 28 because they're not the same term, common term. The negative 3x, it has an x. The negative 28 is just a number. It doesn't have an x. So that's why I wrote it as negative 3x minus 28. I couldn't combine them because they weren't like terms. Now, on the right side is 0 because 28 minus 28. So we have x squared minus 3x minus 28 equal to 0. So when you have a quadratic equation that equals to 0, we can start factoring. So we have to look for factors of negative 28. So factors of c is negative 28, and the sum is negative 3. So I'm not going to do the table here. This is the expectation that you do it to show your work on a test. But here, my expectation that you should know what's the factors for negative 28, where the sum is negative 3. So the factors for x squared minus 3x minus 28 is x minus 7 times x plus 4 equal to 0. And in order to check if these are the correct factors, you would FOIL and see if it matched with the quadratic equation. Now here, I don't have to worry about any dividing of the factors because I didn't do any slide part in the beginning. So I don't have to worry about divide since I didn't do this slide part. If you do the slide, after you factor, you gotta do the divide. Alright, so now we're going to solve for each factor and find our 0. So x minus 7 equal to 0, x plus 4 equal to 0. So here, plus 7 on the left, plus 7 on the right. So we have x equal 7. Over here, x plus 4, so we're going to minus 4 on the left, minus 4 on the right. So x equals negative 4. Alright, so we have two solutions. Now, we have to check if both works. So let's test out x equals 7. We're going to test it out in the original problem. So I'm going to plug 7 into all the x's that I see. So here, log of 7, log base 2 of 7 plus log base 2 of, and again I'm plugging 7 into that x, so 7 minus 3 equal log base 2 of 28. So here, there's nothing I could do, so I'm going to bring that one down. So log base 2 of 7 plus log base 2 of 7 minus 3, so 7 minus 3 is 4, equal log base 2 of 28. And then to check that if the left side is equal to the right side, I have multiple logs and it has a plus, so again I'm reapplying product property. So it's going to be log base 2 of 7 times 4. So again I combine as a condensing as a single log base of 2 and then multiplying what's inside the parentheses. So 7 times 4. So on my left side we have log base 2 of 7 times 4, which is log base 2 of 28 equal log base 2 of 28 on the right side. So we see that log base 2 of 28 on the left side and on the right side, so they're equal to each other, so it worked. So x equals 7 works. Now we're going to test out x equals -4. So I'm going to make some room. And then plug in -4 into the original problem. So log base 2 of -4 plus log base 2 of -4 minus 3 equal log base 2 of 28. Alright. Now, here we have log base 2 of -4. So, there's a negative number inside this log. Now, if we were to work this out, I'm going to write log base 2 of, here, -4 minus 3 is -7. And I bring down everything else. So after I combine -4 and minus 3, I get log base 2 of -7. So in the event when you have a negative number inside a log in any one of them, then it's undefined. It won't work. So here, if you see there's a negative number inside a log, after you check your work, that's where you stop. So here, I'm not going to continue anymore. And since x equals -4 gave us log base 2 of -4 and log base 2 of -7, those are undefined, so therefore x equals -4 will not work. We cannot have negative numbers nor 0 inside each of the logs. So our final solution is the one that actually works, the one that's defined. So x equals 7 is a defined solution, or final answer. Again, we're not using x equals -4 because I plugged in into the original problem and got log base 2 of -4 and log base 2 of -7. So using x equals -4 will give us undefined solutions. In this next example, we have natural log of x equal natural log of 12 minus natural log of x plus 4. So, same thing, one-to-one property applies to log or natural log. If I look on my left side, we have one natural log, so that's good. Which I'm bringing it down. Now on my right side, I have two natural log. So again, before we apply the one-to-one property, we have to make sure we have one log on the right side. So in order to combine as a single natural log, I have to apply one of these properties. So looking at the example, between the natural logs here, it's a minus. So that means I'm going to be applying the quotient property. So it's going to be a fraction. What comes first on my right side is the 12, so that's going to be our numerator. What comes second is the denominator, so x plus 4. There we go, we have a fraction and our natural log on the right side. So, after applying the quotient property, we have one natural log on the left, one natural log on the right side. So they're the same. That means we can set what's inside the parenthesis equal to each other. So it's going to be x equal 12 over x plus 4. And since we have a fraction, if I want to get rid of the denominator and change it where it's not a fraction anymore, I'm going to multiply by the denominator on my right side. And what I do on the right side, I gotta do it on the left side. So, on my left side, I'm going to put the x in front. So x times x plus 4 equal, on my right side, when I'm multiplying, it's going to be x plus 4 divided by x plus 4, which is 1. And then 1 times 12 is just 12. So now we have x times x plus 4 on the left equal to 12. So now I'm going to distribute the x, where we're going to have x squared, that's from x times x, and then x times positive 4 is plus 4x equals to 12. So in this case, we have an x squared, and that means we're going to have a quadratic equation, extraneous solution, more than one solution. So if we have an x squared, that means that we need to factor. But before we can factor, we need to make sure everything's on the same side. My x squared is positive and it's on the left side. So that means I need everything to the left side. We have a 12 on the right. So I want to get rid of the 12 from the right side. Opposite 12 is minus 12. Since I did it on the right, I got to do it on the left. So what we're going to have is x squared plus 4x minus 12 equal to 0. Alright, so now we have everything on the same side. Then you can factor using factors of C, sum of B. Now I'm not going to do the work again. It's expected you should know how to do this when showing the work on the test. So x squared plus 4x minus 12. The factors for this quadratic equation is x plus 6 times x minus 2 equal to 0. So if I were to do the work, I set both factors, each factor equal to 0. So the first one is x plus 6 equal to 0. Solve for it, so minus 6 minus 6. So x equals negative 6. And then our second one, x minus 2 equal to 0. Solve for it, so I'm going to add 2 on the left, add 2 on the right. So x equals positive 2. So I'm going to write over here to make some room. So x equals negative 6 and x equals to 2. Now how will we know if these are the correct factors? You would FOIL and to check if it matches with x squared plus 4x minus 12. Alright. So next is we're going to test out the solutions by plugging in our solution, our zeros, here into the original problem. Alright, first we're going to test out x equals negative 6. So here, plugging in negative 6 into each of the x, so natural log of negative 6 equal natural log of 12 minus natural log of negative 6 plus 4. And if I were to work this one out, it would become natural log of negative 6 plus 4 is negative 2. And I'm bringing down everything else. So if I take a look at this, I see that here there's a negative number inside that natural log. There's a negative number in that natural log. So what just happened is we see we have negative numbers less than 0. So that means if we were to use negative 6, we're going to have undefined solution. It's not going to work. So here, x equals negative 6 will not work. So we're not going to use x equals negative 6 because by checking, we see that in the natural log there's a negative number, and over here in another natural log there's another negative number. So we can't use that. Now we're going to test out x equals 2. Alright. So again, plug in x equals 2 and all the x's. So natural log of 2 equal natural log of 12 minus natural log of 2 plus 4. Alright, so there's nothing I could do on the left, so I'm going to just bring it down. Bring down here this one too, because there's nothing else I can do. Now this one, natural log of 2 plus 4, is just simply natural log of 6. Now if I want to check if it actually equals on both sides, first I'm going to bring down the left side. And I need to condense these two natural log as one. What I see is there's the minus, so I'm going to reapply the quotient property. What comes first is the numerator, so 12. What comes second is the denominator, so 6. So if I check, natural log of 12 divided by 6 is 2. I'll bring down the left side, natural log of 2. Natural log of 2 on the left, natural log of 2 on the right, so this works. So x equals 2 works. So therefore, in this example, the only solution that worked was x equals to 2. X equal to 2 is our final solution. X equals negative 6 is undefined, so we're not going to use that in our final answer. Alright, for our third example, we have 2 times natural log of x equals natural log of negative 2x plus 15. Now over here, it's okay if we have a negative 2x because we don't know what x is yet. So as a equation, it's okay. But what's not okay is what number we plug inside the x, if negative 2x plus 15, what number we plugged in, it comes out as a negative number, then what the solution for x won't work. It's not good. Now, in the previous examples where we had only one solution work and one did not. Now what was common with all three of them, including this one, is that they all had parentheses. Now, certain cases where if in the event you have in the example problem such as 2 times the natural log of the absolute value of x. So take a closer look at this. In our example 3, we have 2 natural log of x. It's just parenthesis. Now the one above it, 2 times natural log of the absolute value of x. So just to review, the absolute value of x is what makes inside become positive, regardless if it's already positive or negative. If the previous example had absolute value instead of parentheses, then there's a possibility that those two solutions, the second one, might work. But example 1, example 2, they only have parentheses. So when we plug in the one that did not work because it came out negative, we didn't change it to positive because it did not have the absolute value lines. So you might have some problems where it's just parentheses. sometimes you might have other problems where it's just absolute value of x. So in that event, if you do have absolute value of x, there's a possibility that both solutions might work. And again, even though in parentheses the last two examples only one solution work, there is still the possibility if two solutions might work. So parentheses, there might be one solution or two solutions or none at all. Now the absolute value is the same thing. One solution might work or two solutions might work. But there's sometimes a rare case where no solution work. So again, keep in mind of the absolute value and remember what it means. If there's an absolute value, it just makes whatever inside positive. Alright, but for example 3, we're just going to use 2 times natural log of x with the parenthesis equal natural log of negative 2x plus 15 with the parenthesis. Alright, now if we take a first glance, we do see that there's natural log, one natural log on the left and one natural log on the right. Now but here, if we were to compare log base b of x equals log base b of y and natural log of x equals natural log of y, we see that there's no numbers except for invisible 1 in front of the log and natural log. So here I got to do the same thing. Now if I take a look at the right side, we see that it is a natural log with an invisible 1, so I'm going to bring down the right side. Now here we have a 2 in front of the natural log. So I can't have that. I can't work as an equation until I get a natural log with an invisible 1. So since there's a 2 in front of the natural log, then I have to use one of these properties. Now, there's no plus, so I'm not going to use product. There's no minus, so I'm not going to use quotient. But there's a number in front of the natural log, so I can use it as a power property. I'm going to rewrite it, meaning moving this 2 as an exponent. So it's going to be natural log of x squared. So the idea was move the 2 as an exponent on the x. So now we have natural log of x squared equal natural log of negative 2x plus 15. So now both sides have natural log with an invisible 1, so we can keep going. And since it's natural log on both sides, following the one-to-one property, I'm going to set whatever is inside equal to each other. So x squared equal negative 2x plus 15. Alright, so since we have an x squared, that means we're going to have a quadratic equation. So before we can factor the quadratic equation, we need to make sure everything is on the same side. First we have to check my x squared is positive, so it's good, and we see that it's on the left side, so that means everything has to go to the left side because my x squared is positive and it's already on the left side. So on my right side, I want to get rid of the negative 2x. So what's opposite of negative 2x is plus 2x. What I do on the right, I gotta do on the left, plus 2x. I also have to get rid of the positive 15. So opposite of positive 15 is minus 15. So minus 15. So doing that, my right side, negative 2x and positive 2x will cancel. My positive 15 and my negative 15 will cancel. So on the right side will be 0. Now over here on the left will be x squared plus 2x minus 15 equal to 0. Alright. So again, we have a quadratic equation. Now we're going to factor using the method of factor to c sum of b. Again, I'm not showing the work. It is expected that you will have to show the work on the test. So the factors of x squared plus 2x minus 15 will be x plus 5 and x minus 3 equal to 0. And again, if you want to check, you would FOIL these two solutions and see if it match what you have when you factor. Now again, here, I don't have to worry about dividing my factors because I didn't have a number in front of x squared. I didn't do the slide method. So if I didn't do the slide method, I don't have to worry about divide. But if I did do the slide method, then yes, after factoring, I got to divide. But in this case, I didn't have to. Now, I'm going to solve for each factors and find their zeros. So, x plus 5 equal to 0, and x minus 3 equal to 0. First one, x plus 5, so I'm going to subtract 5 on the left, subtract 5 on the right. So x equals negative 5. Here, x minus 3 equal to 0, so I'm going to add 3 on the left, add 3 on the right. So x equals to 3. So we have our two solutions. X equals negative 5 and x equals to 3. So, since we have two solutions, we gotta check if both works or if one works. Which one works? Alright. Now the grunt work. So first I'm going to test out x equals negative 5 by plugging into the x of the original function. So 2 natural log of, in parenthesis, negative 5, close parenthesis, equal natural log of negative 2 times negative 5 plus 15. Now over here, I'm not going to mess with it because I want to work with this one out first. So, natural log of negative 2 times negative 5, that's just a positive 10 plus 15, which is a natural log of 25. And I'm going to bring down 2 natural log of negative 5. Now, here, I see that we have a natural log of a negative number, natural log of negative 5. Now, I'm not going to apply the power property where I bring the 2 as a square because before applying any property, we have to check if there's a negative number inside the natural log before doing anything, meaning before applying the properties. So, here we have a natural log of negative 5, so that means that, nope, not going to work. So, even though I apply the property, this would become a positive 25, but again, you always check first before you apply one of these properties. Now, before I apply, I check, and we do have a natural log of negative 5. That's not going to work with us. Nope. So that means x equals negative 5 is not a solution. Now, I'm going to make some room and test out x equals 3. So, 2 natural log of 3 equals natural log of negative 2 times 3 plus 15. Alright, now then I can do on the left side, 2, so natural log of 3 equal natural log. Now negative 2 times 3 is negative 6 plus 15. Now, again, it's okay to have this negative 6 because we're adding with the 15. Now, whatever comes out, it should be positive. If it comes out as negative, nope, we can't use that. But let's check. So natural log of negative 6 plus 15, that's a positive 9. So we're okay here. And then we bring down the 2 natural log of 3. Now, this we check. Alright, both natural log has positive number, so we're good to go. Then we can apply one of these properties. So here, I'm going to apply the 2 as an exponent by using the power property. So using the power property, we're going to have natural log of 3 squared equal natural log of 9. So here we're going to have natural log of 9 on the left and then natural log on the right. So we see that it works. So therefore x equals 3 works. So now before I finish this, again, when we test out x equals -5, had it been 2 natural log of absolute value of x, if I plug in -5 into this one, the absolute value of x, it's going to come out as a positive 5. So x equals -5 might have worked and it would count as part of the final solution. But again, in our original problem, our original example, we have parentheses. Now, again, had it been absolute value, x equals -5 might have worked and probably be part of the final solution. But in the original with the parentheses, the only one that worked was x equals 3. So our final solution is x equals 3.